So I'm going to briefly do a background of Duchenne's muscular dystrophy, even though I'm sure everyone's aware of what it is. And then I'm going to talk about a study that we did where we identified a few novel biomarkers or potential novel biomarkers that could be used in the future. So Duchenne muscular dystrophy, or DMD, is the most frequently inherited muscle wasting disease of early childhood. It's characterized by fibronecrosis, reactive myofibrosis, and sterile inflammation in the skeletal musculature. This genetic disorder is due to primary abnormalities in the large DMD gene, which results in the almost complete loss of the dystrophin isoform DP427. So if you look at this image here, the immunofluorescence, you can see in normal and dystrophic, the DP427 isoform is almost completely disappeared. So normally, dystrophin acts as part of the dystrophin glycoprotein complex, and this image kind of shows how that works and how everything links up. So here's dystrophin and sarcoglycan and dystroglycan, and what this complex normally does would be to link the extracellular matrix component of laminin with the intracellular actin cytoskeleton. So it's important for shock absorption and like transsarcolemal and linkage. So when it's disrupted and dystrophin is taken out, it triggers micro-rupturing of the sarcolemma and calcium-induced proteolytic degradation. So this diagram kind of shows the extended results of DMD. So as I said here, this is how the dystrophin glycoprotein complex is impacted, but there's also an increased cellular stress response, increased collagen and connective tissue, and disturbed pathways like metabolic pathways and these other ones. And of course, there's always going to be an increase of protein leakage and protein release. And these are some proteins that we would expect to be leaked from the muscle. So in addition to the primary muscle wasting, the disease is often complicated by respiratory issues, neurological deficiencies, and scoliosis, and many sufferers would die from an associated cardiomyopathy. So due to the severity of the disease, there's always a push to find new and novel biomarkers. I guess the aim of finding them would be to increase the ease of diagnosis and make it easier to monitor therapy. So these are some of the tissues that we'd be interested in studying, but for identifying biomarkers, ideally you want to be as least invasive as possible, especially for like if you're monitoring a patient's progress. You might need to take samples every few days or every week. You don't really want to be taking that much muscle samples or other samples. So that presents biofluids like saliva and urine as ideal candidates for potential biomarkers. So previously, my lab head, Professor Kyle Endiak, and his former PhD student had done some work on saliva. They'd carried out a proteomic mass spec screening of saliva.
So for a certain extent, though, you kind of get. Oh, sorry, I'm going to move all this out.
And what they found was increased proteins in the kallikrein family. So they identified kallikrein-1 as a potential biomarker. So that was before I was in the lab. And when I joined, we decided to continue the screening of biofluids. So we wanted to compare the urine proteoform of wild-type mice versus that of MDX4CV mice. So MDX4CV is the animal model that we use to study dystrophinopathy. So our associates in the bioresource unit of the University of Bonn in Germany collected urine samples from some of their mice, where it was quick frozen in liquid nitrogen and shipped to us. The mutant status of the MDX4CV skeletal muscle fibers was confirmed with immunofluorescence, and a protein assay was then carried out to determine the protein concentrations of the samples before the samples were then prepared for mass spectrometric analysis through the filtrated sample preparation method. So if anyone is actually interested in the specifics of that process, we also recently published a paper that kind of explains the step-by-step method in STAR protocols. And while it focused specifically on spleen samples, it's pretty interchangeable for any sort of tissue or sample that you could or want to study. So, so for this comparative analysis, our sample size was urine from 7 wild-type mice versus 7 MDX mice, which we then put through the mass spec twice. So we had a technical repeat of each. And what we found was in the MDX4CV urine, we found 21 increased proteins and 8 decreased proteins. So here is the proteins that we found to be increased. So there's a lot of potential biomarkers there that we look at. Like, I mean, you could identify almost any of them as potential biomarkers, but the ones I guess we're interested in are something like titin, nidogin, parvalbumin, and cadherin, and maybe fibronectin. Ones that would typically be associated with like being lost from dystrophic muscle. And then decreased. So we noticed that the decreased weren't decreased as much as the increased ones were. So it's, if we're looking for potential biomarkers, we probably look at what's increased rather than what is decreased. A similar study was carried out in 2014 by Ruelan et al., where they screened urine samples from Duchenne's patients, so not an animal model, like actual Duchenne's patients, and they listed 8 increased proteins and 2 decreased. So we felt that our study was pretty significant because not only did we find more proteins that are increased and decreased, but they were also identified by more unique peptides than in the previous study. So probably the most significant finding, and this heat map kind of shows the expression of the differential proteins. As I said, the probably the most significant finding of our study was the drastic increase of the protein titin. So we identified titin by 65 unique peptides spread across the sequence of the, it's a really large protein, so spread across the whole sequence of the protein. And the previous study that I mentioned had identified it by only 23 peptides, which were all localized to the M band. So we thought it was interesting that we found peptides from across the whole sequence. We used immunoblotting to confirm the increase of titin fragments in MDX urine, which is shown on the bottom of this slide underneath the proteomic fingerprint of titin in urine and in skeletal muscle. And on the side is the peptide expressions. So in healthy muscle, titin would normally be involved in sarcomeric protein scaffolding and cell signaling. So I guess when dystrophin is disrupted and there's sarcolemal leakage, that's why we would expect titin to be leaked as well. And it's kind of confirmed from previous studies it was found in serum, a blood serum. So you probably expect it to be found in a few different biofluids if it's leaking from the muscle. So in conclusion, elevated urine levels of titin, parvalbumin, nidogin, cadherin, fibronectin, and some other proteins could represent interesting potential biomarkers or future candidates for biomarkers. And furthermore, urine sampling presents an ideal source for carrying out non-invasive liquid biopsies as an alternative to highly invasive muscle biopsy procedures. And finally, just some acknowledgements. So to the Kathleen Lonsdale Institute for Human Health Research, who funds some of our research, and to our University Maynooth, and of course to my supervisors, Professor Kyle Lindyik and Dr. Paul Dowling, who are always of great assistance to me throughout my PhD. So that's the end of my talk. If anyone has any questions for me.
I have a question.
Yeah.
Okay, Daniela. Which kind of fibronectin? Because fibronectin can undergo to alternative splicing, so we can have different isoforms.
I'm just checking my image again.
Yes, thank you.
It was FN1.
Ah, okay.
Fibronectin 1.
Okay, so we don't know what fibronectin is. You should go back and study the isoforms.
I would like to ask a question. Do you know if any of these biomarkers would also appear in the urine if mice are exercised, like with intensive exercise?
Yeah.
Is this specific to DMD?
Yeah. So with excessive exercise, like if we expected to see some rhabdomyolysis or rhabdomyolysis, you probably would expect to see some of these as well. So it's not exclusive to DMD. Like anytime the muscle is breaking down, we can expect them to be released. But again, like there's always going to be some difference with Duchenne's. Like there's going to be some systemic differences of what is upregulated and downregulated, and that could affect what's found in the urine. But to answer your question, no, they're not exclusive to DMD. You probably would expect some of them to be found from excessive exercise as well.
And have you tried mice of different ages to see if with development of cardiac disease anything changes?
Yeah. Well, we actually didn't study that yet, but all of our mice were 12 months old. But that definitely would be an interesting future study if you could maybe look at mice from 3 months up to say 15 or 18 months and compare the differences. That would definitely be a good comparative analysis.
Thank you.
And then you could use it on treated mice who've had therapy to replace the dystrophin.
Right, yeah.
That would confirm that your biomarker could be a good endpoint, outcome measure.
If we tested the mice's urine, you mean?
Yeah.
Yeah, yeah.
Should try and get in contact with people who are doing gene therapy.
Yeah, exactly. Like, I mean, if you could upregulate dystrophin and then so that it didn't. Then
you could confirm that this is a real biomarker.
Yeah, yeah, you're right.
Actually, Jay, you make a really great point because our mice, the microdystrophin expressing mice, are specific to cardiac. So that could also perhaps be useful to identify or confirm that any biomarkers are specific to cardiac disease.
Exactly. Yeah, that'd be nice.
So I think there's probably lots of scope to improve the experiment and move further. And even, I mean, ideally you'd want to be doing this sort of experiment in human samples instead of animal models, but I guess that's a bit ahead of where I'm at right now in the PhD. But I mean, urine is really uninvasive, so it wouldn't be too hard, I guess, to actually get urine from some Duchenne's patients and then maybe.
Sei completamente in ombra.
It should be easy because titine was one of the biomarkers that people wanted to use in DMD. No, Lee? I thought they were actually going to use it in clinical trials.
Yeah, I mean, the problem that we're looking at blood biomarkers from a lot of the microdystrophin treated patients. The problem is they're not responding. So it's a bit puzzling. They seem to be better in some ways, but their biomarkers aren't moving.
That's interesting. Okay.
Yeah. And what samples did you take biomarkers from, Lee?
This is all blood. We have urine too, but we
Yeah.
haven't actually looked at the urine. We've been looking at the blood.
Yeah, blood is probably more conclusive, but I guess if you go back to what's more or less invasive, I mean, slightly more invasive to have to take it. But
One
Yeah,
of the
well,
problem- sorry.
Yeah, I mean, we do have urine samples
Yes,
on hundreds of Duchenne patients because we take it
Fatima.
for our imaging. So if you're ever interested in looking at some human samples, you could just write us. I'm sure we can provide them.
oh, great. Thanks for that. Could
One
be
of
some
the
interesting
problems
future
with,
studies.
one of the problems with urine markers is that urine flow is diurnal. And you really need a 24-hour urine to be able to measure accurately and compare things with patients, especially if they're on steroids.
And these are mice.
Can't get mice to pee into a bottle.
Yeah, exactly. Like one of the reasons for sample
Catheterize
size.
the mice. Have you thought putting a catheter?
Pardon?
I mean, if night and day, have you looked at that?
Oh, we haven't looked at that yet. No, like I don't know the exact processes of how they got the urine in the University of Bonn, but I think it was just taken from one time of the day, so not diurnal.